In this video, I'm going to continue talking about covalent molecules by focusing on organic compounds for a little bit. Organic compounds are molecules that are composed of carbon covalently bonded to other atoms like hydrogen, oxygen, and sulfur. Um, Hydrocarbons are ones that are just carbon and hydrogen covalently bonded together. And there's a wide range of molecules that form from just these two elements. And we have a whole set of naming conventions that we won't go into detail here, but I'd like you to be a little bit familiar with them. And so our hydrocarbons usually all involve a prefix that then is connected to an ANE, ENE, or YNE ending. And the endings, the ANE, ENE, YNE, are related to the types of bonds that are present in the molecule. If it's all single, if there's some double bonds present or triple bonds present. And the F in this case, tetra, these are going to correspond to the number of carbon atoms that there are. So I've got an example of propane, one that a lot of us are familiar with when we grill in the summer. That's what's used for kind of outdoor stoves and grills. And it's propane. It's three. The prop is 3 carbon, and the ANE tells me they're all single bonds. So it's 3 carbon atoms bonded together with hydrogens bonded to each of the carbons as well. Ethene, that ETH tells me there's 2 carbons. The ENE tells me there's a double bond. So ethene is going to have 2 carbons only, and they're double bonded together with bonds to hydrogen. And this is a ripening agent that's used in orchards. And there's tons of these. Octane, oct for 8, ANE for single bonds. It's 8 carbons single bonded together with other hydrogens bonded to it. Especially when we get to learning about covalent bonding and structures in more detail, these organic compound structures are actually really helpful to have in the back of your mind. So these are common, we call them functional groups, but they're common patterns that we see in covalent molecules and organic compounds and how they form. And so our hydrocarbons are just carbons and hydrogens. Alcohols always have an oxygen then bonded to a hydrogen. Aldehydes always have a carbon double bonded to an oxygen and then to a hydrogen. We have our carbonic, our acids, organic acids, that have this highlighted carbon double bonded to an oxygen and then bonded to an oxygen to a hydrogen. Ethers always have an oxygen in between 2 carbons. Ketones have an oxygen double bonded to a carbon that's also bonded to other carbons. Amines have a nitrogen that's bonded to a carbon. An amide, that nitrogen's bonded to a carbon that's bonded to a double bonded to an oxygen. And within each of these functional groups, there's a wide array of molecules that have that functional group in it. And so when we're building structures, Lewis dot structures and Vesper theory structures later on, it's helpful to kind of have seen these patterns that arise over and over and over in nature, because they help us like have an idea of what a common pattern might be for how molecules or atoms will arrange themselves together. And so it takes a little bit of the guesswork out of deciding what a structure is from a chemical formula. And then if you go on and take organic chemistry, we'll dive into the very, very rich field of chemistry that goes into all of these different functional groups, their reactivity and how to manipulate them.